Okay, so even if you're not finished, let's have a stop. This is going to be an opportunity to, yes, reiterate what we were doing, but we're also going to take it a bit further. So we've looked at quadratics, right? And we've said a quadratic is an expression where the leading power is 2. And we've mostly looked at quadratics in what we call general form, right? ax squared plus bx plus c. What we've introduced to you today is what we call linear factor form, where we have a times x take p times x take q. All right, maybe you can see if you expand these, if you multiply it, x times x gives you x squared. The highest power is still x squared. So these are different ways of presenting the same equation, and they both tell us different things. What we're going to do now is we're going to start with a quadratic in general form. We're going to determine all of this information, and then we're going to plot it on the Cartesian plane. So I'm going to pop up to some of these things as we need them, and we're going to find them in this order. Firstly, we're going to find the y-intercept. The y-intercept occurs when x is 0, and we can extract that straight from our general form here. If I put 0 into this equation, that goes to 0, that goes to 0, I'm just left with minus 8. All right? In fact, for the quadratic in general form, the y-intercept is this value. Here's the general form, the y-intercept is minus 8. So I've got my list over here. My y-intercept of this quadratic is minus 8. Next, we want to know the roots. Now, we can't see the roots from looking at that, but one of the skills we've been practicing is factorizing, right? If we want to know the roots, we want to know what are the values of x that make this quadratic equal to 0. All right, so we can make it equal to 0. And we know how to factorize this, okay? We could use quadratic formula, we could complete the square. We're just going to use the cross method. I'm looking for two numbers that I multiply together to get minus 8. And when I add them together, I've got positive 2. Noel, you can see them?
Minus 2 and 4, isn't it?
Minus 2 and positive 4, very good. And it doesn't matter what order you write them in, okay, because order of multiplication doesn't matter. Next, we're going to apply the null factor law. So we're going to have x take 2 is 0, or x plus 4 is 0. I don't need my brackets anymore. And so I've got the roots, x is 2 and x is minus 4. All right, so let's put them in here. 2, minus 4. Now, before we do move on, I want to point out one thing here. I've said we've got two ways of presenting the quadratic. Notice in maths how we're always working down, right? And I've said this is equal to this. Here's the general form. Here's the linear factor form. If we wanted to move from here to here, okay, from the top down, we factorize. If we want to go from this step back to this one, we would expand. Yep, we can use FOIL. I'm just going to do it, you don't have to copy this part, I'm just going to do it really quick to show you. Okay, if we have x take 2 times x plus 4, we use FOIL. We multiply it. X times x is x squared, x times 4 is 4x, minus 2 times x is minus 2x, and minus 2 times 4 is minus 8. Okay, we can collect the like terms in the middle here. 4x take away 2x is plus 2x take out. Look, that is the same as what we had above. Okay, so these quadratics, even though they're written differently, they're the same graph, the same equation, two different ways of writing it. All right. Over the course of this unit, we will look at 3 different ways. But to start with, we've moved from general form to axis-intercept form. We've got the roots. Excellent. Next, this is where we're getting a bit more particular. Is we're saying what are the coordinates of that vertex, of that turning point? Okay. Now, if the a value is positive, if it's larger than 0, if it's a positive number, then the shape of the quadratic opens up like this. All right? And a good way to remember it is if it's positive, it's going to be a happy face. If you're positive, you've got a happy, you've got a smile. All right? If the a value is negative, it's opening downwards. All right? So that's going to dictate the shape a bit for us. So we can look at this one, and we know this a value out the front is positive 1, which means it's going to have this shape. All right, so I can already anticipate which way it's going to open up. And so because it opens upward, the vertex there is what we call a minimum point, a local minimum, right? So we're going to say, what are the coordinates of that point? So we can sketch it very precisely. Well, we've got two ways. The first way we've sort of covered already. I've said the vertex needs to be exactly halfway between the roots. Exactly halfway between those 2 points. So that is that roots added together divided by 2. That will tell you the halfway point. Let's do that first. So we identified our roots as 2 and minus 4. So then I'm going to call this the axis of symmetry, or we can call it the AOS, axis of symmetry, AOS, and it's equal to P plus Q divided by 2. Our roots are 2 and minus 4. So we're going to go 2 plus minus 4, all right, P plus Q divided by 2. All right, I'm using this form here. And this is going to give me minus 2 divided by 2, minus 1. This gives me minus 1. That means the x value, the point halfway between them, where my minimum, I know it's a minimum because it's opening upwards, the x value is minus 1. Now, that's one way we can do it. We can even do that from the general form using this formula, okay? Minus b divided by 2a. Here's the general form, right? This is the general form, and if we're looking at the general form, A is positive 1, B is positive 2, C is minus 8. All right? If we do minus B, it's told x equals minus B on 2A. That's going to be minus 2 divided by 2 times 1. That's minus 2 on 2. It's minus 1. It's the same. Two ways of doing the same thing, all right? That's the x value of the vertex, all right? The axis of symmetry. We've got the x value, all right? But for coordinates, we need a y value, right? So our vertex here, the x value is minus 1. Whatever the axis of symmetry evaluates to, that's the x value of the vertex. How do we get the y value? We put this number into the quadratic. And we can put it into either form. We can put it into the x squared plus 2x take 8. We can put it into the x take 2 times x plus 4. Because they're the same function, it doesn't matter. But we're saying, when x is minus 1, what's the y value? All right, let's put it into this form. We're going to have minus 1 squared plus 2 times minus 1, and then take away 8. All right, so all I've done is put the number 1 where the x is in the function. Positive 1, take 2, take 8. This is minus 10 plus 1. The y value is minus 9. All right, so we establish we can use either of these processes. That's the axis of symmetry, so that's the x value of the vertex. That's going to be the y value by plugging it in. Okay, I said if you put it in here, you'll generate the same answer. All right, let's show you quickly. Remember, we have y equals x take 2 times x plus 4. That's it factorized. If I put x is minus 1 there, I'm going to have minus 1 take 2, minus 1 plus 4. Okay, minus 1 take away 2, that's minus 3. And here, minus 1 plus 4, that's positive 3. And minus 3 times positive 3 is negative 9. Okay, same value. All right, you can see putting the x value, these functions are the same, so we expect the y value to be the same. Now, I'm showing you multiple ways of doing the same thing up here. When you're solving these problems, you don't need to go through every single process, right? I'm just trying to point out the connections. Anyway, over here we've generated all of the information we need to plot it on the Cartesian plane. So I'm going to do that graph here. We've got roots at x is 2 and minus 4. 1, 2, 3, 4. They're the roots. Okay? We have a y-intercept of minus 8. I'm going to put that there. And we have a vertex at x is minus 1, y is minus 9. So that means across 1, down 9. So if I have my scale, it's going to be there. That's the minimum point, right? And so then our function goes through all of those. And we've drawn it perfectly. The extension on what we did last time is we've included the coordinates of this point, right? -1, -9. That's the minimum. Here we've got -8, +2, -4. Okay, so list all this information and then smash it on a graph. Make sure you label your axes. Give it a sketch. Okay, so with the next example, I'm not going to go over the same skills multiple times. I'm just going to do it one way. And you can use either process that you like. So I'm going to start rubbing out the example, except the graph. I'll leave the graph up for a little bit. Are there any questions about that? So we're starting with the quadratic in general form. So our next example is -2x squared, take 6x plus 8, y equals. Okay, so firstly, I'm going to rub this out so I can fill in this information again. Y-intercept when x is 0. The y-intercept here is +8. Okay, so we can get that one straight away. That's the first piece of information. All right, so if you look at your sheet where I've got from general form, you can see I've got the process, and I'm just following those number steps, right? Number 1, identify the y-intercept. Number 2, factorise the quadratic. Now you can factorise it as it is, but I think an easier way to factorise this is to first recognise 2 is common to all of those numbers. So we can pull 2 right out the front. In fact, we can pull -2 out the front and be left with this. All right, -2 times x squared gives me -2x squared. -2 times +3x, and then -2 times -4 gives me +8. So we can do that, and why that's useful is because now we have a monic quadratic trinomial, and they're much easier to factorise, right? We can look at that. We're looking for 2 numbers that multiply together to be -4, and then you add together to be +3. All right, and so remember, if you can't see it straight away, you can use your calculator to help you. All right, you can use the calculator for you, but you just start going. Okay, what are the multiples of x squared, x and x? Multiples of -4, so it's going to be 4 and 1, or it's going to be 2 and 2, right? One of them has to be negative, okay, because we have the product is negative. And so what I'm looking at, I'm going 4 times 1, and I need it to add to 3. So if I make that negative, right, it's going to be 4x take x gives me +3x. That's our solution, right? So -2, x plus 4, x take 1. If this is a skill we've gone over this, but if it's a skill you need to practice, please let me know. I can provide some resources. All we've done there is factorise the quadratic. This function and this function are the same. They're different ways of saying the same thing. Next, what are we trying to do? So factorise the roots. So what's the process say next? Identify the roots. Quadratic's been factorised. Well, the roots occur when y equals 0, when the quadratic equals 0. We can divide both sides by the -2, chuck it out. It doesn't affect the roots in any way. We can apply the null factor law. We're going to have x plus 4 is 0, or x take 1 is 0. We get x is -4, or x is 1. They are the roots. Okay. Next, so we've got the roots. Next, identify the axis of symmetry. So we've got 2 ways to do this. All right, you can use this formula or you can use this formula. Either of them is going to generate the correct solution. So let's go for, I like the second one. We're going to go the axis of symmetry. Oh, list these up here first. So -4, +1. The axis of symmetry is -4 plus 1 divided by 2. That's going to be -3 on 2 or -1.5. Okay, next we need the y value, right? Next we need the y value. So we've got the x value for the vertex, we need the y value. And so we need to put that into either of these forms. We can put it into the top one, or we can put it into the bottom one here. Both are going to be a bit chunky, a bit clunky. So this is where we would use our calculator. And so what we're saying is, well, when x is minus 1.5, y equals, and I'm putting minus 1.5 where the x is, I'm going to put it in this form, just thinking that's a bit easier, times minus 1.5 plus 4, minus 1.5 take 1. And you can evaluate that on your calculator, right? That's going to determine the y value.
We're doing which one is it? The x of the symmetry?
Yeah, we're putting the x is minus 1.5 in. Yep. So I'm going to start sketching the graph. Can someone evaluate that in their calculator? So we've got roots, x is minus 4 and positive 1. I might just point out one other really important thing here, and that is that in this quadratic, the a value is negative. Okay, look here, the a value is negative, which means it's not a happy face, this time it's going to be a sad face. It's opening downwards. It has a maximum point, okay? And the coordinates of that maximum point are going to be that x value. Anyone got the y value? Charles is on it. Minus 4, 1. What else? We've got y-intercept of 8. Minus 1, I'm going to put them on minus 1, minus 2, minus 3, so 1.5.
27.5.
Yep, sounds good to me. I'm going to shove that down a bit. Minus 1, minus 2, minus 3. Okay, so remember I've said the axis of symmetry. Let me explain to you why we call it the axis of symmetry. Is because that x value is the middle of the quadratic. It is symmetric about that point. Okay, we established that x value is minus 3 on 2. And what did you get? Minus 27 or something, Charles? Perfect, thank you. 27-ish, that'll do. Alright, and so I said minus 1.5, here's minus 1, here's minus this halfway. Notice how it's exactly halfway between these two roots. Very good. Okay, so that one was a fair bit shorter process because I wasn't doubling up, I wasn't showing you lots of different things. Definitely use your calculator to help you. So that's the skill we're working on. I'm going to bring up Desmos because there is one thing I want to show you. I'm going to bring up your graphics calculator because I want to show you how we can use our calculator to check our answers. So I'll just hit pause here and I'll set. So what we're doing, we're going to go into the graph mode on your calculator. So in menu, you go to graph, you press enter, execute, and you're going to type in there the equation. Let's do this one we just did, this one, minus 2x squared take 6x plus 8. So when you want to put minus, we're not putting take away, we're putting minus. That's why there's two options here, like that one down there is for when you're putting a minus in. This is for when you're taking away. So we're going to have minus 2x squared, excuse me, minus 2x squared, take 6x. Okay, remember when we're, for the x, we're pressing that button there, and then plus 8. X is this button. Press this button here. X, theta t. All right, Jolie?
Yeah.
Alright, so once we've typed it in, we're just going to press enter. And look, we can see some of it, but we can't see the whole thing. All right, we can't see the maximum point here. And so that's a problem with our V window. Remember, X min, X max, Y min, Y max. We need to change, Noah, we need to change our Y max so that we can see this point. So we need to bring up our V window. That's F3. F3 for V window. See there, F3. And we know, Charles calculated it for us, our Y max is 27. If you can't see it, just zoom out. All right, you can zoom out to 100. I'm going to change it to 30 so that I'll be able to see it nicely. All right, beautiful. I reckon it was 27 on 2, wasn't it? It was 14 and a half. Okay, so there's the graph. All right, so V window just changed the Y max. Now I want to show you a few things that we can do here. All right, so you can like to solve these problems, you could literally just type that in to your calculator and graph it from your calculator, like copy it. Okay. In the test, we're going to be saying, using algebraic techniques, show that the x-intercepts are these, show that the y-intercepts are that, so you can't, like you do need the algebra skills, but let me show you. G-solve, okay, that's going to bring up lots of options. Oh look, F1, roots, we know what roots are. If I press that, that takes me to those x-intercepts. So we performed this whole algebraic process, and it's given us exactly what we would expect, okay? Root to x is -4. We can press the across arrow, it'll bring up the other root. X is +1. All right, I'm going to go back to the G-solve button. What else is there? Max, okay, max. Well, because we had a negative A value, we have a maximum point. I can G-solve the max, 1.5 and 12.5. All right, so we might need to fix this a little bit. 1.5, it's not really significant, but when you've got the calculator there, be particular about it. 1.5, 12.5. So we can G-solve the max. It's given us the X value, the Y value. One more thing, G-solve Y-intercept. Okay, when X is 0, what's the Y value? +8. So all of that information can be checked on your calculator. So you've got these sort of safeguards along the way to make sure you're on the right track. All right. So that's enough to have a go at the next part, which is 2D.3, just question 2. All right. So finding all that information, graphing those quadratics.